Group 17A. My name is Juan Yuna,
My name is Nathan Bajarski.
And I'm Henry Oberly.
and today we're going to be presenting our findings on rotational molding. So rotational molding is a manufacturing process which is also known as rotomolding. And the name comes from the way that this type of molding is used. It is a casting technique which does not require pressure in order to make the molded parts, but instead uses rotation and heating in order to spread out the plastic into all the cavities of the mold. This is why this type of casting technique is ideal for hollow parts. And it also offers designers a lot of freedom since virtually any shape or form can be made.
The concept of rotational molding dates back to the ancient Egyptians, who used it in the creation of ceramics. However, the first major predecessor to rotational molding as we know it today was a rotomolding machine patented to R. Peters in 1855. This machine was primarily used to create artillery shells. In the 1910s, Baker and Kirk's adapted this technology to create hollow chocolate eggs, although it has been speculated that the Swiss may have been creating these chocolate eggs using rotomolding since the 1600s. In the late 1930s or early 1940s, plastic became the most common material used with rotomolding. Some of the first products that were created using this method were children's toys. The late 1950s and early 1960s, though, could be considered the true birth of modern rotomolding. At this time, new grades of powdered polyethylene and the hot air oven were introduced. These technologies remain important to modern rotational molding.
Now I'm going to play a video that explains the process of rotational molding. So here we start with the mold, which can be made out of steel or aluminum, and it's really flexible on how it can be made. That's a great part of rotational molding. And then we add in the powder, plastic powder, and that will be pre-measured and can just be kind of placed in there. Doesn't really need to be anything fancy when you put it in. And then it begins to be spun around, and the powder starts to coat all the edges. And at the same time that it's spinning, it's also being heated up. And what that allows it to do is when it melts evenly across all the edges. As you can see right here on the video, it's kind of just rolling against the edge. It's not being flung everywhere. It's very controlled and nice and slow. It's not fast, it's pretty slow. And then because one of the advantages of rotational molding is you don't need a high pressure mold, there's a little hole that lets out all the pressure from the inside while it is rolling around. And then next, it is cooled, and it is still spun while it's cooled because you don't want it to drip all over while it's cooling. You want to keep everything evenly coated on the outside. And then removed, and your part is right there. It's good to go, ready to be shipped out. Here's a little bit faster of what I just said. Goes around, there's the process, and you can reload the same mold. And now here's something cool, is you can use lots of different molds. It doesn't just have to be a sphere. You can do like a cylinder or something that when you spin it, it can be evenly coated. And here they just put a little inject into the cylinder. And you can also put like patterns right on the edge of the face because it's a little bit difficult to etch on after the fact. So you can make all your graphics in the same step as when you make your part.
After having discussed the process of making rotomolded parts, we will now discuss the types of materials often used for rotomolding. As you can see, about 84% of rotomolded parts are made using polyethylene resin, due to the many properties of polyethylene that make it ideal for rotomolding. The main factor driving polyethylene's popularity is its excellent cost to resistance and durability ratio. Polyethylene offers a lot of durability, strength, and resistance for a relatively low cost. Nevertheless, other materials are often chosen for more specific applications. These applications include high stress or high temperature environments, environments that involve a lot of corrosion, and environments that have a lot of impact strength upon the rotomolded parts, as well as many others. As you can see on the table on the right, it outlines the advantages and disadvantages of the most popular materials used in rotomolding.
Some advantages of rotational molding include the low cost of the tools used to create it. For example, the molds can be made out of aluminum, which is a fairly cheap metal. Another advantage is the consistent wall thickness, meaning the part will be the same all the way around, which helps with the high durability and high strength. Since it is all one part, it all solidifies as one part, there's no weak points, and since it's not exposed to high pressure, all of the plastic will solidify consistently. Another cool thing is that you can add logos or symbols to your part, to the mold, to go just right on the part when you make it. The disadvantages, however, are it takes a while to make. Because it spins so slow because it has to coat the part evenly, it does take a long time, up to 3 hours for just one part. There's limited options for materials. Mostly you just use polyethylene, and that kind of costs a little bit more and then also the thickness makes it cost more. And then there's not a lot of repeatability since the molds, although they're cheap, they will break after a while. And then the labor cost is high because the human has to measure out the plastic, put it in, and seal up the molds all themselves.
As we discussed in an earlier slide, polyethylene offers certain properties that make it ideal for rotomolding. These properties include its ability to be easily ground into a resin, since the plastic has to be made into a fine powder before it can be used in a rotomolding machine. It is thermally stable. It has good low temperature physical properties, which includes impact strength. It is relatively low cost in comparison to other plastics used in rotomolding. And it is available in a wide range of densities and melt indices to fit both low stress and high stress applications. So the table on the left outlines certain properties that are affected by the melt index and density of the polyethylene. An increase in density often increases the stiffness, but lowers the impact strength of polyethylene. And these are the two most important qualities in a rotomolded part, since we require it to withstand high stress applications using as little plastic as possible. The table on the right shows the most common types of polyethylene and its various advantages and disadvantages.
Although rotational molding can be used to create a variety of products for many different fields, some of the main products produced using rotational molding include water and chemical containers and tanks, toys and playground equipment ranging from doll heads all the way up to large slides for playgrounds, traffic cones, dividers, and road signs, boats, kayaks, canoes, and other floating devices, and other common household objects.
So in conclusion, rotomolding is a simple method for creating many plastic products, which can be large and complex, or they can be small and simple. The majority of rotomolding is done with polyethylene, although there are other polymers that can work with rotomolding. And products created using rotomolding tend to be very durable due to their consistent wall thickness, their thick corners, and then the lack of deformations due to the constant or at least fairly consistent pressure within the system. The disadvantages of rotomolding are its slow speed, its high raw material cost, low repeatability due to needing to replace the molds frequently, and then its high labor cost. And in cases like that, some of the alternatives like blow molding are much better choices. Despite its downsides, rotomolding can be used to create a variety of products, which range from toys, storage containers, boats, and kayaks, and then a bunch of other products which are used in everyday life. So really, rotomolding is just a very good manufacturing process for working with plastic.